We have a very crowded room. All right, so thank you for joining this session. I'm going to try to be as entertaining as I can because it's after lunch and I'm sure you're, having a good digestion right now. So today's session is about building the cloud-native future with application environments for hybrid and multi-clouds. And my name is the first one on the left that you see there, Cesar Saavedra. My Twitter handle is right there. I'm a technical product marketing manager at Red Hat. And unfortunately, my colleague, Shaf, got sick and didn't show up. Well, couldn't come. So it's just gonna be me. So let's just get started because we only have 35 minutes. And I would like to give you this presentation and then follow it with a demo and have you participate in the demo. Hopefully everything works. So if you have a cell phone, have it ready. A little later, you'll need it. So how many of you are developers? Raise your hand. Okay. And all right, so are you guys working for some like a big company, or are you independent? Raise your hand if you work for someone else, for a big company. Okay, so the three of you are independent. Okay. So medium-sized. Oh, I'm sorry. Yeah, I should have said. Okay, sorry. Medium. I should be more accurate when I describe things. Good. So most of you have an employer. Okay. So so you must understand the difficulties nowadays with IT environments. I'm sure your IT environments are made up of different databases, different runtimes. Maybe you have ERP systems you have to interface to or with, and it's really a very heterogeneous environment, and despite that, you have to continue to deliver good solutions to your customers, right? With great user experiences, and also, stay ahead of the competition. But as you know, the cloud is a big move that IT departments and organizations are making now because of its benefits, right? A lot of companies are moving or scaling up to cloud vendors during high peak times, or are just doing development and testing on the cloud and then deploying on premise. But a lot of folks are looking at the cloud as a way to improve productivity, reduce costs, and the cloud really doing this even adds to the complexity that you're already seeing in your IT environments. And so wouldn't it be great if you could have an environment on top of which you run your applications, despite the heterogeneous nature of these environments, have an environment that can provide you a consistent application development experience, no matter if you're developing on premises or on the cloud. And also an environment that can allow you to, whether you're running your application on premises, you can easily scale to the cloud and then back down to on premises, for example. An environment that can allows you to use modern techniques like agile development to do your development. And also an environment that you can't just throw away all the applications that you're currently using, right? It's an impossibility. You have to be able to evolve and take advantage of new methods and approaches of development while maintaining what you have. So you need an application environment that supports existing applications as well as new applications. In an environment that allows you to use capabilities and features that have been already engineered to work together, so that you don't have to spend a lot of time cobbling things together and putting, integrating different components together and just become productive fast. And the benefits of this type of environment would be, the ability to optimize existing applications and innovate seamlessly across different clouds. It would increase your productivity while having reliable operations. It would allow you to scale for unpredictable workloads, whether if you're in retail, for example, Christmas is a high peak traffic time, so you can scale up to the cloud and then back to on-premise. And also, it will give you the ability to not be locked into a cloud vendor. Okay. Also, I'm sure you've heard of cloud native development. So it's key for this environment also to support the concepts of cloud native application development, which is an approach to developing an application that takes advantage of the cloud benefits, but it's also based on 4 key tenets. It needs to be based on services for architecture. It needs to be API driven, so all the microservices and all the components that are part of your architecture communicate with each other via APIs. Number 3, it needs to be container based or container focused, and this is basically an installation layer or an abstraction layer that abstracts away your dependency on a specific cloud vendor and allows you to be portable. And also, lastly, when it comes to processes, it needs to support DevOps processes, CI/CD, as well as modern deployment techniques like A/B testing, blue-green deployment, canary deployment, and then those type of deployments. So, so when we talk about this application environment, we call it, how do you build a hybrid cloud application environment? So this environment needs to be a cohesive and unified set of capabilities engineered to work together to automate, integrate, and accelerate the creation of portable cloud-native applications. And it needs to have 5 sets of capabilities. It needs to have, as you develop and automate your business processes, it needs to have capabilities that are related to process automation and decision management. And as you develop these processes, you need to integrate these processes with backend systems like ERP systems, whether it's Salesforce or SAP or databases. So you need to have integration capabilities. You also need to have runtime. So whether it's Quarkus, I know if you heard about Quarkus, you've heard about MicroProfile this week. Simple Java, if you're writing, plain Java objects like POJOs. You also need runtimes capabilities. And a rich set of developer tools, and ideally this would be a developer tool or developer tools that allow you to and support this seamless ability to create applications without you having to depend so much or write too much to the underlying infrastructure. For example, if it's whether it's on premises or on the cloud, you need to have developer tools that allow you to have the same developer experience, whether you're developing on the cloud or on premises. And lastly, you need capabilities that are related to containers and containers orchestration. And as I mentioned before, these capabilities are important because this is the abstraction layer that allows you to not just be able to automatically scale up and down, but it also gives you this wrapper or this abstraction layer above any cloud vendor and even on premise. It basically enables is a big enabler of the portability or the ability to have the same experience, whether it's on premise or on the cloud. But as a business and as an organization, whether you're in insurance or financial or automotive, you're running a business, right? So what really matters to you as a developer and as a developer that works for a business, it's the actual business logic and the systems that support the business, which is actually what runs in the container. Okay, so that's what's important to you guys. So that matters to the business. Also, what's between the containers, as you develop microservices or applications within containers, you need to be able to integrate them and also integrate those to your existing application. So what's between the containers also matters to the business. And also what's around the containers. So these are ready-to-use development tools, things like messaging. If you think of Kafka, AMQ, API management, like 3Scale in our case, business rules management systems, function as a service solutions, process automate like BPM process automation solutions. These are all ready-to-use tools that you can use to start writing that will help you accelerate your implementation of business logic. So this is also important. And also the integration and the engineering that is put together within these different components to work together so that, and this is important because you don't want to spend a lot of your time making BPM work with Kafka or making microprofile work with AMQ, right? If all this integration work has already been done for you, then that's more time that you'll have innovating instead of making things work together. So now let's switch to how do we provide this application environment to you using Red Hat. So within Red Hat, and I'm sure a lot of you know Red Hat because of Linux, right? And a lot of people are unaware that Red Hat has a lot of middleware products, and these are basically the ready-to-use tools that can help you write business logic. So we have Red Hat integration that obviously fills in the capabilities, the integration capabilities that I mentioned before in the application environment concept. Red Hat Runtimes, which includes not only runtimes for existing technologies like application servers, but also modern runtimes like microprofile, Spring Boot, Ver.x to do reactive programming, for example. Red Hat OpenShift platform is the product that gives you the container capabilities and container orchestration capabilities that act as this abstraction layer that make you independent from any cloud provider. And Red Hat Process Automation is the product that we offer you that fulfill the capabilities related to process automation. And lastly, when we talk about developer tools, the product is CoreReady Studio, which is based on EclipseJ. And we also have a version that you can run on your laptop, but EclipseJ is a browser-based IDE that runs on OpenShift. And what this means is, as a developer, all you need to write code is a browser. You connect it to CoreReady Workspaces, and then you start developing your code. Now your code doesn't reside on your laptop; it resides on the cluster. So that's all centralized. You don't have to install anything on your laptop. You can start writing code right away, and all that is maintained for you. So that's a developer can become productive really fast. Now, Red Hat Runtimes, I'm not sure if you have seen this diagram before, but it contains OpenJDK. I'm not sure if you were aware of this, but Oracle has started charging for supporting OpenJDK, so January of this year. So it's basically opened up an opportunity for other companies to also provide support for OpenJDK. And we do that. Java EE is an existing approach and technology and specification to write enterprise Java applications. So in there we have JBoss CAP and OpenLiberty. Java Web, so that's JBoss web server, which is Tomcat. We support that too. Serverless and function as a service. That's something that is a roadmap item, but it'll be part of Red Hat Runtimes. Spring Boot, JavaScript for Node.js, Quarkus will be there. It's a roadmap item. Thorntail, which is what we currently use for microprofile implementation. Reactive programming, we have for that we have Vertex. Also includes data grid if you want to cache data in memory, as well as AMQ broker if you want to do messaging. Includes also SSO for security, as well as a launch service to make you productive quickly. So Runtimes, as you can see, offers runtimes for existing well-established technologies, as well as modern microservices technologies, all included in this product offering. Will help you get started faster. It simplifies the container development because all of this can run on OpenShift, which is a Kubernetes offering from Red Hat. That includes automation of DevOps and standardized tools and processes. All of this on an OpenJDK supported by us. So an example of a customer that is using runtimes is Banque de France. And for the sake of time, you will get a copy of this presentation. You can read up later on. And I want to get to the demo quick. So I'll skip some of this. I'll just browse over this really quickly. But some of the benefits, for example, from them using runtimes, is that they were able to consolidate their runtimes into our product, and and it takes a long time to make a software selection, by the way. And if you go with us, then we already curated that for you, and you have access and support for all these runtimes, and you basically are free to pick the right tool for the right job or for the right task. The next set of capabilities are the integration capabilities from the application environment are fulfilled by Red Hat integration. In here we have Red Hat Fuse, which is based on Camel. Just in case, everything we do is open source. And Fuse is actually the productized version of Camel. We have Red Hat AMQ, which includes not just AMQ, but also Kafka. So Kafka is pretty big right now, so Red Hat AMQ includes that. It supports the containers. I mean microservices, as well as API management solution. If you are a company that is doing API first development approach, Red Hat 3Scale is a good option for you to do that. And again, all of this runs on OpenShift. This is an example of an organization that is using Red Hat integration. Lufthansa Technik is a German company, and they are using 3Scale and Fuse, and they were able to put actually a service together that they can share with partners. So this has increased the level of collaboration with third-party developers, and they've been able to see reduced costs and become also the scalability using our middleware on OCP. OCP is OpenShift, has been another benefit that they've seen. And the last set of capabilities that I'm going to mention is process automation. So this includes BRMS, a full BRMS system that includes a complex event processing, business rules, and business optimization as well. This is called Red Hat Decision Manager. And the Process Automation Manager is a BPM solution that includes a process manager as well as a builder to build the UIs for the process when it's time to interact with humans, right? So, and this is an example of a European company that is, using BPM, our BPM offering, and is seeing benefits from it, like increased customer engagement and empowering their employees to focus more on the goals of the company. We also have a product called Red Hat Managed Integration. Have you heard of iPaaS, Integration Platform as a Service? So this is an environment that is a SaaS offering. So you don't have to install anything. Basically we stand up an environment for you, and you can do all the development there. The nice thing about this Red Hat Managed Integration is that first of all, we manage it for you, and it's hands-free management. And it includes this tool right here, Solution Explorer. So this tool is really neat in the sense that you can pick your use case. For example, if you want to do APIs using API management, you would select that second box right there. And what it does is once you finish this, you can call it a wizard. This, you click and you pick what you want, and you finish. It'll set up the entire cluster with the components that you need. So, and then it spins everything up, and then developers can start developing in that environment. So it automates everything for you, and it has pre-integrated a lot of these components for you. These are some of the components that are included: API Designer, messaging, mobile capabilities, connectors, application runtimes that I mentioned before. There's a bunch of integration patterns as well in there. And includes also code-ready workspaces, and everything runs on OpenShift. All right, so overall, and to finish this up before we jump into the demo, is so when using Red Hat middleware to instantiate an application environment, a hybrid cloud application environment, these are the 4 key benefits that you get. Productivity. Again, these capabilities that are included in our solution have been engineered to work together. That would allow you to be more, to spend more time innovating instead of trying to, connect things together and integrate components together. Reliability. All these capabilities have been tested for you at the factory, and they're ready to be used. They're enterprise grade, so you can have peace of mind that you will get operational reliability. Flexibility is the third one, and this is the fact that within our solution you get, as I mentioned before, languages for your existing applications, well-established frameworks and libraries, as well as microservices runtimes, for example, so that you can use the right tool for the right task. And lastly, all of this allows you to do hybrid cloud deployments as well as multi-cloud. Again, this is possible because everything is running on our Kubernetes offering. So as long as you write your application on OpenShift, then you can basically just run that in any cloud provider. So you can get OpenShift on the Google Cloud, on Amazon Cloud, on Azure, which is the Microsoft Cloud, on IBM Cloud, and it can run on premise. So if you run it on OpenShift, you can pretty much it's portable to any. You have no lock-in to the vendor cloud to the cloud vendor. High-level picture. This is basically an application environment with Red Hat. Would look like this. Red Hat middleware in the middle. Everything runs on OpenShift and is optimized. All of our middleware is optimized around OpenShift, and the tools on the right, code-ready workspaces. And this is a company that is basically using this concept of application environment. They created actually their own cloud. It's an on-premises cloud, and they are, they're very proud about that. They are the first bank to do that in the Middle East, and they use an API-driven architecture, and they've been able to reduce operational costs incredibly. They get 10 times higher workload density on virtual servers and 200 times on physical servers. And they're using Kafka, Red Hat Fuse AMQ, as well as 3Scale, all of it running on OpenShift. So what makes us different? Again, open source reciprocity. Everything we do is open source. We actually give back to the community. So we consume, but we also participate and enrich the upstream projects. That's basically the open source project that we derive our products from. We are supported and trusted open source. We're Kubernetes native. All our middleware is optimized for OpenShift. It supports multi and hybrid cloud deployments. So it makes basically your applications cloud agnostic. And all the capabilities that come in it have been engineered to work together. So onto the demo. So this demo is it's a multi-product demo, so includes a lot of what I've covered so far. And it's the concept is there is a disaster in this city, and then there is incidents. So that's somebody that needs help, and then there is rescuers, and then there's a concept of missions. So you will become a rescuer, and then you're gonna be you make yourself available. You'll be assigned a mission, and then you'll see in the map when you go rescue somebody, and then you take him or her to safety. Okay, it's a demo that we've been given, at conferences and to customers to showcase, how all these components have been engineered to work together, and how you can use, basically the portfolio of products that we offer to build a solution. And it's available to partners, and this slide doesn't really concern this presentation. So this is a high-level feature of the demo and what it's using. So it's using integration capabilities. You'll see in a minute. We're using runtime, so you'll see that we're using Spring Boot. We're using Thorntail, Bird.x. Everything runs on OpenShift. We're using integration capabilities. We're using Kafka. Everything was developed using core-ready workspaces. We're also using the process automation capabilities, and you'll see that in a minute. And everything is the observability aspect is using Grafana and the metrics that are captured from every running process in container and pod. So Prometheus and Grafana are the components that are capturing the metrics and displaying the metrics. Core-ready workspaces is the development tools. Everything runs on RHMI, which I mentioned before, Red Hat Managed Integration. And I already talked about the incidents. There's a process. When you are assigned a mission, there's a process that is followed, and you'll see that in a second. You'll be a responder. I already mentioned the missions. And this is a higher level picture of how the flow works, like a high level architecture here. There's a disaster simulator that we'll see in a minute, which is based on Bird.x. There's a Node.js front end, which you'll see on your phones. There's SSO, which is single sign-on. There's an API management component that is basically managing all the APIs, and all these services, as you can see, use different runtimes. Bird.x, Spring Boot, and Fuse is an integration capability that is being used for the weather alert service. Now the back end, we're using Data Grid, which is in memory Data Grid, AMQ Extremes, which is Kafka. We're using process automation and Prometheus and Grafana for the metrics. All right. So before you do this, don't scan that yet. I want to show you. So I'm going to log in as a user here, and hopefully it won't fail me. You see that? So when you log into with your phone, you're going to see this map. Okay. So this is what starts the whole simulation. So I'm going to create 10 incidents. That means 10 people need help. I'm going to create let's just create 25 responders. And when I do that and I create the incidents, what you're going to see is you're going to see the requested box is going up now to the number of incidents that are happening. And the incidents are the yellow circles, and then the boats are the rescuers. Okay, so when like myself, so the first thing that you would need to do is go to the mission, and then you mark yourself where you are. I do a click, that's me, and then you make yourself available. Okay, and then what's going to happen is if I'm fast enough, a mission is going to be assigned to me, and then you will see. We can see the process. Refresh that. So what I'm thinking is I'm going to have you actually at this moment do it. If you pull your phone, open a browser on your phone, or you can scan this. Can you scan that with your phone? And then open it. If you click on that, it'll open it in your browser. Please create a user first. Just be creative. Say John Doe or Mickey Mouse or something, and assign yourself a username and a password, and then you'll be able to go into the dashboard. So what you get is that you get a sign-on screen, hopefully, and it says username and password like you saw earlier, but on the bottom it says create user. So go ahead and create a user, and then you should be able to participate in this demo. Okay, what happened is everybody was saved already, I think, so I need to create more incidents. I want to create 100 incidents. 100 incidents. Submit. There you go. they're being assigned super fast. Let me see if I got one assigned to me. Available. Waiting to receive. Okay, waiting to receive a rescue mission. Okay. Okay, you know what? I think the internet is failing me. Yeah. You can just say for the certificate just accept it. Yeah, accept it and move on. Yeah. So I'm having some issues with the internet, but I have 5 minutes, right? Okay. So yeah, we only have 5 minutes. And I'm not sure it'll work with the internet, with the Wi-Fi, but wanted to show you this real quick. So this is OpenShift, and these are all the pods that are running for this demo. So this is the disaster simulator. This is the screen that launches the incidents. And then there is an emergency console. So if you click on this link, it'll open up the console here that you're seeing. And there's a bunch of other ones. There's a mission service. There's also a process viewer, which would open up a graph, a BPMN graph showing your mission and how it is being traversed. And basically, the process graph would show you mission has been selected based on priority, and then it's assigned to you, and then it figures out where you are, and it'll try to assign a mission that is closest to you. And then there's a metrics. I wonder if this is going to work. Let me see. There's a monitoring capability here. It's in Grafana and Prometheus that is being is collecting the information that way. There we go. So if I open the browse Grafana maybe. There. Okay. So once I select the dashboard for the emergency response, this is basically tracking lots of metrics of the running process. Okay, and it tracks it real time. See how the graphs are moving? So this gives you the observability capabilities that we mentioned before of this solution. 3 minutes left. So I'm not sure if we were able to log in. It's just I'm having issues with and it's too bad that I didn't have a wired connection. Sorry if you were able to log in, but if you're able to log in, you'll be assigned a mission, and then you will see the little boat going to the mission you were assigned. This is not assigning me a mission. Let me start more incidents. I'll do 30 here. Any questions? We only have 2 minutes left. Yes. So, you mean as a Kubernetes-based solution? Right. So the OpenShift supports, multi-tenant. So you can have multiple users. It has a concept of namespaces, so it separates the environments that way. So yeah. Oh, I see what you're saying. So, right. So, right, right. So that so there are two ways to do it. So if you wanna completely isolate each customer in their own cluster, then you could have assign and stand up a cluster just for them. So if you have 10 customers, you will have to manage 10 different clusters. The other option is having them all on the same cluster and separate them using namespaces. Right. The mm, could you repeat that again? Right, 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 right. Because then, yeah. Well, remember also, if it's multi-tenant, you have to be able to calculate resources or do capacity planning for all the tenants, right? If it's a single cluster with multiple tenants, you have to make sure that you give the cluster enough memory and enough CPU to handle all the all the tenants. So, whether you do it at the application layer through microservice, or whether you do it through an API management solution, where you can route the calls depending on the user. Um, you know, you're moving the. Tell you what, let's take this offline, yeah, because the other session has to start and have to stop.